This is the homework helper for workbook 7-3 over triangles. So let's go ahead and take a look at the questions at the top here. Now all the questions on the top are based on the same premise, that the angles of a triangle have to add up to make 180 degrees. So in all of these questions, you want to make sure that when you're done, your angles, your three angles that you figured out, do all add up to 180 degrees. We'll go ahead and pick out some of the ones that might have some things that might confuse you here and make sure we can handle those. Let's start off with number 1. You've got a right triangle there. Now what's not marked here is this angle. But what's expected at this point is that you know that this L shape, no matter which way I draw it, right side up, upside down, forwards, backwards, left, right, whatever, you have to know that that is 90 degrees. So we have 90, although not stated, we're supposed to know that. And that this one here is 49. So 90 and 49 added to what number make 180? Well, what they want you to do is work this like you're solving an equation. X plus 90 plus 49 equals 180. We can, of course, simplify that a little bit and rewrite that as x plus 139 equals 180. And then we would solve the equation just like we did when we were solving equations back in the previous chapter we studied. We're going to subtract 139 from both sides. So when we do that, we find out that x is 41 degrees. All right, let's keep looking down here. Let's go down here to number 7. In number 7, they're asking us to find x in the isosceles triangle. What they don't necessarily state directly, but what's assumed you know, in case you don't, here it comes. When you have an isosceles triangle, that means that two of the sides are the same. What it also means is that two of the angles are the same, what they call the base angles. Those are the two angles that are not formed by the congruent sides. So here in this illustration, what they're saying is that these two sides are the same. So not this angle, right, because that's made by those two sides, that vertex, that corner there, right? Not this one, but the other two have to be exactly the same. So we have 64. So we're saying what plus 64 is going to get me to 180? Now, some of you are looking at this and saying, well, wait a minute, why are you doing what plus 64? I know that these two angles together are going to make what I'm missing here, y. And then once I get that, I'm just going to split it in half. So when I subtract 64 all the way across the board here to solve the equation, I find out that y is, in this case, 1/16. That's going to have to be split among these two angles now. And again, because this triangle is isosceles, that means that these two angles are exactly the same. So here, take that 1/16 and divide it by 2 now for x. When I take 1/16 and divide it by 2 for x, I get 58 degrees, which is the answer to question 7. Now in question 8, they're talking about an equilateral triangle. We know the term equilateral implies that all three sides are congruent. What it also means when the three sides are congruent is that the three angles are congruent. So all the angles in that triangle are exactly the same. Well, there's only one way to make that happen, because remember, no matter what way I draw it, how long the sides are, those three angles still have to make 180. So I'm going to just take 180 and divide it amongst the three angles, and that will give me the measure of one angle. Well, 180 divided by 3 is 60, so the angles here are 60 degrees each in question number 8.